Good morning, one and all. Myself Jyoti, who is a lecturer in Chemical Engineering Department in HJ Government Polytechnic, Bengaluru. So we were learning about the particle technology, and we have already learned in our last session of this subject about the size reduction. What is size reduction? What is the necessity of size reduction? What are the different forces involved in size reduction? Whether it is a compression force, attrition force, mm, impact force, the shear force, and we have learned about the different types of grinding, open circuit grinding or the closed circuit grinding, and also we have learned wet grinding and dry grinding process. What are the advantages and disadvantages of using the wet grindings? These are all been covered in the last session. So in continuation of these topics in the last session, today in this session we will learn about the laws of crushing. So what are the laws involved in the crushing? So about Rittinger's law, Hicks law, and the Bond's law, and what is the formula and used in this. So what is the energy? The main these laws mainly tell about the efficiency, the crushing efficiency, the energy, the efficiency involved during the crushing process by these various laws. So ವಾಟ್ ಈಸ್ ಎಫಿಷಿಯನ್ಸಿ ಎಫಿಷಿಯನ್ಸಿ ಅಂದರೆ ನಿಮ್ಗೆ ಏನು ಅರ್ಥ ಆಗುತ್ತೆ ಹೌ ಎಫಿಷಿಯೆಂಟ್ ಯು ಆರ್ ಯಾವುದೋ ಒಂದು ಕೆಲಸ ಕೊಟ್ಟಾಗ ಅದನ್ನು ಎಷ್ಟು ಎಫಿಷಿಯೆಂಟ್ ಔಟ್ಪುಟ್ ಎಷ್ಟು ಕೊಡ್ತೀರಾ ಎಷ್ಟು ಎಫಿಷಿಯೆಂಟಾಗಿ ಕೊಡ್ತೀರಾ 100% ಕೊಟ್ಟಿದ್ದೀರಾ ನೀಟಾಗಿ ಮಾಡಿದ್ದೀರಾ ದ ರಿಸಲ್ಟ್ ವಿಲ್ ಗಿವ್ ಯು ನಿಮ್ಮ ಕೆಲಸ ಕೊಟ್ಟಿದ್ದು ರಿಸಲ್ಟ್ ವಿಲ್ ಗಿವ್ ಯು ಯುವರ್ ಎಫಿಷಿಯನ್ಸಿ ಸೊ ಸಿಮಿಲರ್ಲಿ ದ ಸೈಜ್ ರಿಡಕ್ಷನ್ ಪ್ರೋಸೆಸ್ಸಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಎಕ್ವಿಪ್ಮೆಂಟ್ನ ಯೂಸ್ ಮಾಡಿ ನೀವು ಕ್ರಶ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ಆ ಎಕ್ವಿಪ್ಮೆಂಟ್ ಎಫಿಷಿಯನ್ಸಿ ಎಷ್ಟು ದ ಕ್ರಶಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಎಷ್ಟು ಅನ್ನೋದನ್ನು ತಿಳ್ಕೊಳ್ಳೇಬೇಕಾಗುತ್ತೆ ಅದರ್ವೈಸ್ ಯೂಸ್ ಆಫ್ ದಟ್ ಎಕ್ವಿಪ್ಮೆಂಟ್ ಇನ್ ಆರ್ಡರ್ ಫಾರ್ ದ ಪರ್ಟಿಕ್ಯುಲರ್ ಪರ್ಪಸ್ ಮಾಡ್ತಿದ್ದೀವಿ ಅಂದಾಗ ಎಫಿಷಿಯನ್ಸಿ ಏನು ಅಂತ ಗೊತ್ತಿಲ್ಲದಿರ ಸುಮ್ಮನೆ ಯೂಸ್ ಮಾಡೋದು ಆ ಎಕ್ವಿಪ್ಮೆಂಟ್ನ ಈಸ್ ಆಫ್ ನೋ ಯೂಸ್ ಇಟ್ ಈಸ್ ನಾಟ್ ದ ಎಕನಾಮಿಕಲಿ ಫೀಸಿಬಲ್ ವಿ ಕ್ಯಾನ್ ಸೇ ಸೊ ಇನ್ ದಿಸ್ ದ ಕ್ರಶಿಂಗ್ ದ ಸೈಜ್ ರಿಡಕ್ಷನ್ ಪ್ರೋಸೆಸ್ the crushing efficiency na navenanta define ಮಾಡ್ತೀವಿ it is being defined as a ratio of the surface energy created by crushing to the energy absorbed by the feed material ಯಾವುದೋ ಒಂದು ಫೀಡ್ ಮೆಟೀರಿಯಲ್ನ ತೊಗೊತೀವಿ ಕ್ರಷ್ ಮಾಡ್ತೀವಿ ಒಂದು ಎಕ್ವಿಪ್ಮೆಂಟ್ನ ಯೂಸ್ ಮಾಡಿ ಆಮೇಲೆ ನಮ್ಗೆ ಏನು ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೋ ಆ ಏನು ಕ್ರಷಿಂಗ್ ಪ್ರಾಡಕ್ಟ್ ಸರ್ಫೇಸ್ ಎನರ್ಜಿ ವಿಚ್ ಇಸ್ ಬೀನ್ ಕ್ರಿಯೇಟೆಡ್ by the product after crushing to the energy absorbed by the feed material is nothing but the crushing efficiency. It is denoted by eta here. Eta will give you ES into AP minus AS divided by WN. What is ES? Eta is nothing but your crushing efficiency. Crushing efficiency, you know, the ratio of the new surface which is being the surface energy which is being created by to the energy absorbed to the feed material. So this is ES into AP minus AP. AS will be your surface energy created to the feed material. So energy absorbed by the feed material will be in terms of W into N. W suffix N. So E suffix S is nothing but what? Surface energy created, and AP is the surface area of the product minus the surface area. ಎಷ್ಟು ನಾವು material feed na ತಗೊಂಡಿದ್ದೀವಿ ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಬಂದಿದೆ so that into energy surface creation SP minus AP minus AS surface area of the feed, and WN is what? The energy absorbed by the feed material. So the crushing efficiency formula you have to remember, eta is equal to what? ES into AP minus AS divided by WN. So what are these the terms also you should able to explain. So Rittinger's law, based on the crushing efficiency, the Rittinger's law states that the work required for crushing, ನಾವೇನು ಕ್ರಷಿಂಗ್ಗೆ ಎನರ್ಜಿ ಬೇಕು, the work is a form of energy. The work which is being required for crushing is directly proportional to the new surface area created. So this is for fine grinding only. This applies, the law is applicable only for fine grinding. So the energy which is being required for crushing is directly proportional to the new surface area created. So energy is nothing but W here. This is directly proportional to the new area created. Created ಅಂದ್ರೆ ಏನು ನಾವು ಪಾರ್ಟಿಕಲ್ ಆಫ್ಟರ್ ಸೈಜ್ ರಿಡಕ್ಷನ್ ಪ್ರೋಸೆಸ್ ಏನು ಬಂದಿದೆ, ಸೈಜ್ ರಿಡಕ್ಷನ್ ಪ್ರೋಸೆಸ್ ಮೊದಲು ಎಷ್ಟಿತ್ತು ಅವೆರಡು ಮೈನಸ್ ಮಾಡೋದ್ರಿಂದ ನ್ಯೂ ಸರ್ಫೇಸ್ ಕ್ರಿಯೇಟೆಡ್ ಕ್ವಾಂಟಿಟಿ ಸಿಗುತ್ತೆ. So that will be your efficiency. W is equal to P divided by M naught is equal to Kr into 1 minus D2, 1 divided by D2 minus 1 divided by D1. This is the formula. This is the energy, the work required for the crushing is directly proportional to the new surface area created. New surface area is what? 1 divided by D2 minus 1 divided by D1. So directly proportionality constant is being replaced by the Kr, that is nothing but the Rittinger's constant. P divided by M naught, the energy, the work required can also be taken in terms of the ratio of P divided by M naught, where the P is nothing but the power required by the machine and Kr is nothing but the Rittinger's constant, and M naught is the feed material to the machine. ಒಂದು ಮಿಷಿನ್ ಯೂಸ್ ಮಾಡಿ ನಾವು ಕ್ರಷಿಂಗ್ ಮಾಡ್ತಿದ್ದೀವಿ ಅಂತ ಅಂದರೆ ಎಷ್ಟು ಪವರ್ ಬೇಕು, ನಾವು ಎಷ್ಟು ಫೀಡ್ ಮೆಟೀರಿಯಲ್ನ ಆ ಮಿಷಿನ್ಗೆ ಹಾಕ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಅದು ದ ವರ್ಕ್ ರಿಕ್ವೈರ್ಡ್ ಫಾರ್ ಕ್ರಷಿಂಗ್. So that will be equal to, is directly proportional to the new surface area created. The new surface area created will be 1 divided by D2 minus 1 divided by D1, where D2 and D1 are the surface mean diameter of the feed particle and the product respectively. The product and the feed particle respectively. So this is about the Rittinger's law. So these are all laws will be asked in the exam. You have to remember and you have to state the law as it is only, as the statement only. So this is about the Rittinger's law. You have a Kick's law also. So it takes tells about the work required for crushing of the feed material is proportional to all the logarithmic ratio between the initial and the final product. So logarithmic ratio between initial and the final product is also directly proportional to the initial and final product, but it is given as the Kick's law states that it is proportional to the new surface area in namge work required eniruttೋ for crushing the feed material in order to create a new surface area is proportional to the logarithmic ratio between the initial and the final product ಅಂತ ಹೇಳ್ತಾರೆ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? So initial ಮತ್ತೆ final product, that you have to remember. W is equal to again P divided by M naught, where Kk is directly proportional to ln D divided by D. So the proportionality constant is being replaced by the Kick's constant, where capital D and small d are the size of the feed and the product respectively. And what about the P? We have already learned what P is. P is the power required by the machine, and M naught is the quantity of the feed material which is being fed into the mass of the feed material which is being fed into the equipment in order to crush in order to have a reduction process. So W is nothing but the work required for crushing the feed material. That can be taken in terms of power required to the feed into the material. So this is the Kick's law. So you have a Bond's law also. So it states that the work required for crushing is proportional to the square root of the surface to the volume ratio of the product. So the work required is proportional to, so work required for crushing is proportional to what? Surface to volume ratio of the product. The dP is nothing but surface to volume ratio of the product. The dP is nothing but surface to volume ratio of the product, Sp divided by Vp. So this is for each, after the reduction process by a particular equipment, you need to check all the laws. So by using this all the laws, you can compare the efficiency of that particular equipment. So these all will be done in your second semester of particulate technology laboratory. So where dP is what? Diameter of the product, and it is directly proportional to the surface volume ratio of the surface to volume ratio of the product, square root of the surface to volume ratio of the product. dP is nothing but Sp divided by Vp. So Kb is a proportionality constant, that is the Bond's constant. Similarly, M naught is nothing but mass of the feed. Sp is nothing but the specific specific area of the product, and Vp is the specific volume of the product, we can say, and P is the power supplied, and W is the work done. So what is a work index? The work index is being defined as, these all can be defined the same way, the amount of the total energy which is being required to reduce a very large material to a small material, such a size that 80% of the product ನಮ್ಗೆ ಏನು ಸಿಗುತ್ತೋ that has to pass through the 100 micrometer screen. 100 micrometer screen ಅಂತ ಅಂದರೆ, ಇವಾಗ ನೀವು ಜರಡಿಗಳು ತಗೊಂತೀರಾ, ಅಕ್ಕಿ ಹಿಡಿಯೋ ಜರಡಿನೇ ಬೇರೆ ಇರುತ್ತೆ, ರಾಗಿ ಹಿಡಿಯೋ ಜರಡಿನೇ ಬೇರೆ ಇರುತ್ತೆ, ಇನ್ನೂ ಫೈನ್ ಪ್ರಾಡಕ್ಟ್ ಹಿಟ್ಟು ಹಿಡಿಯೋ ಜರಡಿನೇ ಬೇರೆ ಇರುತ್ತೆ, ಬೇರೆ ಬೇರೆ ಜರಡಿಗಳಿರುತ್ತೆ. ಸೊ ಆ ಮೆಶ್ ಓಪನಿಂಗ್ ತೂತ್ಗಳು ಏನಿರುತ್ತೆ ಅದನ್ನು ನಾವು ಮೆಶ್ ಓಪನಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಮೆಶ್ ದ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೆಟ್ ಆಫ್ ಸೀವ್ಸ್ ಅಲ್ಲಿ ಯು ಹ್ಯಾವ್ ಅ ನಂಬರ್ಸ್. ಸೊ 200 ಮೆಶ್ ಸೈಜ್ ಅಂಡ್ 100 ಮೆಶ್ ಸೈಜ್, all those numbers. And the larger the number, the larger the number of the screen which is given to the screen, the finer the product you will get through that screen. ಸೊ ಇಲ್ಲಿ ವರ್ಕ್ ಇಂಡೆಕ್ಸ್ ಅಂತ ಏನು ಹೇಳ್ತೀವಿ, ನಾವೇನೋ ಒಂದು ಎಕ್ವಿಪ್ಮೆಂಟ್ ತಗೊಂಡು ಕ್ರಷ್ ಮಾಡಿ ನಮಗೆ ಏನು ಮೆಟೀರಿಯಲ್ ಬರುತ್ತೋ ಅವಾಗ in order to crushing, the total energy is being involved. So the energy which is being involved in terms of kilowatts per ton of the material, it is being taken in terms of the kilowatts energy which is there in kilowatts per ton of the material. Per ton of the material, 1000 kg of the material. In order to reduce ಆ ಎಕ್ವಿಪ್ಮೆಂಟ್ ಎಷ್ಟು ರೆಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ, ಲಾರ್ಜ್ ಮೆಟೀರಿಯಲ್ ಟು ಸಚ್ ಎ ಸೈಜ್ ಸ್ಮಾಲ್ ಮೆಟೀರಿಯಲ್ ಆಗಿ ಮಾಡುತ್ತೆ. ಸೊ ದ್ಯಾಟ್ ನಾವೇನು ಪ್ರಾಡಕ್ಟ್ ಬಂದಿರುತ್ತೋ ದಟ್ 80% ಆಫ್ ದ ಪ್ರಾಡಕ್ಟ್ ಹ್ಯಾಸ್ ಟು ಪಾಸ್ ಥ್ರೂ ದ 100 micrometer screen. That is called the work index. So the work index WI is given by 0.03126 into WI, where KB is nothing but root of 100 into 10 power minus 3. This is a constant. Where dP is in millimeter and P is in kilometer. When you do the problem, you'll understand this. So if the 80% of the feed passes through that mesh size of the dP, the 80% of the product passes through mesh. From the above equations we get, so after solving equations we'll get, this is the equation you have to solving, you don't worry, you have to remember these equations. So W is equal to P divided by M naught. This is being used in a laboratory in order to find out the work indexing by using the Bond's law. 0.3162 WI into 1 divided by root of dPb minus 1 divided by root of dPa, where dPa and dP are the particle size of the feed and the product in millimeter respectively. The work index will include the friction in the crusher, ella include agutte. Hence the power given by the above equation is the gross power, we can say. So these are the various laws you have to remember in order to find out the efficiency of a particular the equipment after feed, in order to, for the size reduction of the very large particle. So whether it is of the Bond's law, Kick's law, the Rettinger's law, you have to see the efficiency through these laws. So I hope you have understood the laws of the crushing laws of Rettinger's law, Kick's law, the Bond's law, and the work index. And you can, for more knowledge, you can go through these textbook which is being given here, the McCabe Smith and W.L. Smith, the Badger, W.L. and Baccaro. That is the title of the book, Introduction to Chemical Engineering. These books are all available in the market and also in our libraries of the particular colleges. So you can go for extra knowledge, you can go through these textbooks. I hope you have understood from this session and benefited from this session. And thank you.